Welcome to the acid-base titration lab. We're going to cover a number of topics shown here in the slide, each of which is covered in your lab manual. But the primary focus of this will be on the titration itself, mixing an acid and a base together, and a chemical reaction, as well as the pH scale. We'll perform part A of this experiment using 3 pieces of pH paper. We're going to spot one with an acid, one with a base, and then spot one after an acid and base have been mixed. Note the container that held the pH paper. You will see a scale on the front of it. It ranges from red at the top left all the way down to a very dark blue. That is the relative scale of acid to base. Here you can see the first dot, the acid, is definitely on the red side. As a general memory device, neutral colors with pH paper tend to be about yellow, and the warm colors, the reds and the orange, tend to indicate an acid, and the cooler colors, the greens and the blues, represent bases. Here you can clearly see this was a base. Next, we'll take a few drops of acid and a few drops of base and mix them together and see if the color is either the original red color or the original dark blue color or something in between. Let's now look at the pH of the solution that we made by mixing the acid and the base. To it, we're going to add an indicator, and that clear solution will stay clear if it's acidic, or it will turn pink if it's basic. Let's move to Run 1, Instructor Demo. By the way, Run 2 will not be done. Run 2 is a student run, and well, this is an internet class. But after that, we will move to Section 3, where we do the titration of an acid of unknown concentration. As you can watch the setup here, make sure that you read along with it in your manual and you're following the procedure carefully. I would like to mention that the M you see on these bottles stands for molarity. That is our unit of concentration. What you need to know now about that is that the higher the M value, if you will, the more concentrated it is. By the way, molarity stands for moles of material in a liter of solution. Let us now have a look at the equipment setup. We're going to use 2 burettes, and they are going to be rinsed with deionized water first to make sure that they are clean. And we'll run a little bit of that water through there to make sure that the burette is indeed working. 1 burette will contain the acid that we're going to use. We've labeled that A, and the beaker that we're going to use with that is also going to be labeled A, and burette B is going to stand for base. So A for acid, B for base. For both experiments, for all of our experiments today, we're going to use 0.50 molar base, 0.50 molar sodium hydroxide. And to find out the amount we use, we're going to have to use a burette. We're going to start with a particular volume. Here you need to record that. That would be your initial base volume. And after we add base, we'll take a final reading, and of course the amount of base that we used is going to be base final minus volume of base initial. It having been rinsed clean, we're now going to fill the burette A up with acid, and we're going to drop the meniscus down to a point at which it is on scale. This will be your initial volume of your acid. At this point, we're going to add some acid to our Erlenmeyer flask. And here you can see the final volume of acid added. Volume of acid added, of course, is equal to your final volume minus your initial volume. Now let's titrate the acid solution with the base. Because there's an indicator, what we would like to do is add the base until it's within 1 drop of the solution staying pink. At that point, we will have reached the equivalence point. That is the point at which the amount of acid equals the amount of base. It is from that point that we can do our calculation and determine from the known concentration and amount of base what the concentration of the acid is, because we know how much acid we started with. Here we added 1 drop and it was pale pink, but it looks like we're about to lose the pink color. That suggests we're within 1 drop of the equivalence point. Let's add 1 more drop. And there we have it. A pale pink color within 1 drop tells us we're at the equivalence point. Perfect. So how much base did we use? There's the final volume. Subtract the initial volume for that. You have the amount of base used. Knowing the volume of the base, you now have everything you need to calculate the molarity, or M, for the acid. You know the volume of the acid. You know the molarity of the base, 0.50 molar for all of this experiment. And volume of the base you just determined. As a bit of a clue, the molarity for the acid that you calculate should be somewhere between 0.5 and 1.5 molar. If you get a value outside that range, you need to go back and perform the calculations again. Here, as a reminder for this section, we will have an acid of unknown concentration, but the base will be the same one that we used before, the 0.50 molar sodium hydroxide. Here are the initial readings for burette A, the unknown acid, and burette B, your 0.05 molar sodium hydroxide. Let's see what our final volume of base was. There it is. And with that, you have all of the information you need to calculate for the acid of unknown concentration, what that concentration is. Perform that MV equal MV calculation in the Run 3 box shown on line 20, showing all of your work in detail, much as you should have done at line 12 for Run 1. As a reminder, we did not do Run 2 and we did not do Run 4. As usual, make sure that all of your work is recorded to the correct number of sig figs. And with that, this experiment's a wrap.